Now, let me give you an example that would really show you in a beautiful way the full power of the technique. Suppose that you are an economist analyzing two situations. Before, let me call that situation theta 0, you were trading, you were observing data for subjects that were trading or buying freely at price P. And perhaps you observe them at several prices P. And what you observe is that, this is the data, that their demand function, x star of P, is just given by 9 divided by P minus 1. That's what you observe. Now what you want to do is you want to be able to predict what the consumer surplus is going to be at a situation in which there is a new policy, which we're going to denote by theta 1, in which subjects trade freely at P, and you decide freely how much to buy, but also get 2 free units. So on top of what they buy, they always get 2 free units of X. So notice that in this case, to make it clear, the X consumed is equal to X bought plus 2. And that's the policy that takes place after the change. Question? That's the question we're going to try to solve, is compute what is the consumer surplus after the change. It looks hard, but you see that if you systematically apply all of the recipes and ideas that we have been seeing so far, you will be able to characterize the solution fairly easily. So let me show you how to solve the problem in detail. And this, by the way, will be great preparation for your practice problem and also for the problem set, because it brings everything that we have learned so far together into a single example. Now we're going to do this in several steps. Step 1 is going to involve recovering the utility function from the observed demand. So this is what, let me call this the recovery step. Now the data is the demand function x star of P is 9 over P minus 1. I hope that you can notice, sorry, this is a 9, that this is almost identical to the example that we solved in the previous problem, except that we had a 10 here in the problem. So basically, analogous to previous video, or to previous example, we can solve this and recover that the preferences of the subject are u of xm are equal to 9 times the log of x plus 1 plus m. Now look at the second step of the solution, which is going to involve using the preferences or the experience utility function for the individual that we just identified, we just recover from the behavior that we observe at theta 0, and we're going to use that to predict what the behavior is going to be at theta 1 after the policy is introduced, and let's call that x star of theta 1. How do we do that? Well, the first thing that we want to do is write the maximization problem, which is going to be maximize by freely any amount that is not negative your utility function. Now what's going to be the utility function? It's going to be 9 of logarithm of whatever you buy plus 2, because you get those units for free, plus 1, this term. So I'm going to erase that just to simplify the notation and call it x plus 3 plus the wealth minus the cost of buying what you buy, which is px. Note that is not p times x plus 2 because the 2 extra units are free. Two small comments to make sure that there is no confusion. First, this looks like a standard maximization problem in which the benefit function happens to be this and the cost seems to be this. But please notice that x now, let me emphasize this, is not the amount that you consume but the amount that you buy. And there is a gap between the two because of the 2 free units. Nevertheless, it's still the case that let's call this We can call this a B function, and we can simplify by taking that, and that looks like a cost. So it has a standard structure that we have been seeing over and over again, and therefore we can apply the same recipes. So that implies that we need to care about the marginal benefit and the marginal cost. The marginal benefit of how much you buy is just the derivative of this, which is 9 divided over x plus 3, and the marginal cost is just p. So the intuition looks very similar to the first order conditions of every problem that we have seen. You can plot b prime there, and b prime of 0, by the way, crosses at when x is 0 is 3, and then it goes down progressively. So what do we get? It's exactly like before. If the what is x star of theta 1, which is, remember, what you buy, this is the amount bought. What do we get? We get that if the marginal cost is too high, let's say it's up there, so if the price is greater or equal than 3, you buy 0. And if it's below, it's given by, let's say something like this, is given by the intersection of the two curves, which means that at an interior, b prime is equal to c prime, which implies that 9 over x plus 3 equals p. And if you solve that, what you get is the formula for the amount that you buy, which is just 9 divided by p minus 3 for p less than 3. So now we have a full characterization of what you buy as a function of any possible price in the market. Now we are ready to tackle the third step and final one, which involves predicting what the consumer surplus is after the introduction of the policy. Now, I hope that you're getting the intuition that the consumer surplus really tracks in some sense or is related to what the behavior is. So not surprisingly, we're gonna show you that the consumer surplus at theta 1 is going to depend on what the price is, and in particular, it's going to be different when the price is greater or equal than 3 than the price is less than 3. Actually, let me move this a little bit to the right in case I need more space to write the formulas here. Now let's see why. First, what happens when the price is greater or equal than 3? We know that we are in this case of the demand. We know that the consumer buys nothing. He still consumes 2 units of the good for free. So what is his utility after the introduction of the policy is 9 logarithm of 0 plus 3, so logarithm of 3, plus W minus P of 0 because he buys nothing. That is the utility at the policy. And what is the utility of no trade for this subject? The utility of no trade, which I'm going to write in this term, is going to be basically get no X. That is the utility of the status quo, where he just consumed his wealth, and no X. So that is going to be 9 times the logarithm of 1 plus W. Notice that this is 0. Notice that these two cancel. So this is basically equal to 9 logarithm of 3. Now the question that is more interesting is what happens in this price range, for example at that price, when the subject actually does something. I hope it's intuitive for you to see that basically the subject is going to get this amount of surplus just as before for the first 2 units, and then he's going to get this much area of additional surplus. Let me call that A of P. Why? Because he's allowed to buy this many extra units. Let me call this theta 1 at P so it's clear. He's allowed to buy this many extra units at that price P, and that generates that extra additional net benefit for the subject, for all of the logic that we have been seeing. Now the question, of course, is what is A of P? So what is A of P in this area? So let's compute what this area is. It's going to be the integral from here to here of the area between these two curves. And that's going to be the integral of the margin of this marginal b function, which is given by this, so of 9 divided by x plus 3, and above the p, so minus p, the x. And this is going to go from 0 to the amount demanded at p, but we know that the amount demanded of p is 9 divided by p minus 3. Now this requires a little bit of grunging through the integral, but if you do that, you're going to get that this is equal to 9 times the log of 9 divided by p minus 9 logarithm of 3 plus 9 minus 3p. So what does the consumer surplus at theta 1 ends up being? Is the surplus from the first 3 units, which is 9 log of 3, plus this area of p that we just computed. And if you do the algebra, this term and that term cancel, so you will just get the expression 9 logarithm on 9 divided by p minus 9 minus 3p. Please notice another good trick in economics, in physics, in anything that involves modeling is just to check your math using little tricks, that when price is equal to 3, this term cancels. So this is a plus. I made a mistake here in copying the algebra. This term cancels, and this term becomes 9 logarithm of 3, which is identical with this, which should be the case, since at price equals to 3, the two expressions should be the same. So this is good news. The math has worked, and now we have a full expression of what the surplus looks after the introduction of the policy for any price P. Let me finish with some remarks to put this example in perspective. First, by the time you understand this example, whether at the first pass or you need to check it a couple of times, I want you to take your hand and clap your back, as I'm doing right now, because the example, understanding the example means that you are understanding an enormous amount of economics. To understand this, you have put together the entire material for the first 2 units of the course. You know how to compute demand functions. You know how to derive utility functions from demand functions. You understand consumer surplus. And more importantly, you understand the kind of exercise that economists want to do, which is predict out of sample. Now, another remark. If you are representative of the history of classes that I have taught at Caltech in the past, some of you at this stage, even after the first pass, are going to say, my God, this is easy, intuitive, and cool. Others are going to be a little bit overwhelmed by the amount of math that you can see in this graph. But for those of you, for that later group, here comes the third remark, which is, please, I'm begging you, don't lose track of the forest for the trees. Don't lose track of the big picture that you understand for the little details in the math, the little tricks that you've done. So let me emphasize the big picture here that I know you understand it, you have made it so far. First, we start with some data, which is a demand function that was estimated from data and was given in one situation that we're going to denote the status quo or theta 0 or something like that. And the whole goal of the exercise is to predict what's going to happen to demand and sometimes to consumer surplus in a whole other situation, given that we only start with behavioral data, so we don't know the utility function. So we go through 3 steps. First, we use the tools that we have derived on the previous 2 videos to derive the utility function. And if you have made it this far, you understand that. So that is a little bit of detail on the integration, but there is nothing complicated there. A little bit of calculation detail. Now, once you have the utility function, everything is like the first part of Unit 2 and the math of Unit 1. The next thing that you just do is write down the maximization problem so you can predict what the consumer is going to do, the action that is going to take as a function of prices, as a function of the parameters of the policy. Here we did that. We wrote the maximization problem. We characterized the amount that the subject bought, and it was standard. It was completely standard things that you know at this stage how to do. And finally, once you have the demand function, comes a step that requires a little bit more thinking, but also you should know how to do by now, and you understand how to do even if some of the details of this integral are a little bit complicated, which is that all you have to do is, given that you know what the consumer has, predict what its consumer surplus is at that situation. And that's all we did, apply the definition of consumer surplus, which is U at optimum given theta 1 minus U at status quo of no trade. And we applied it as a function of P because behavior depends on P. That's it.